The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone. Thank you all for joining us for our webcast today. We will be discussing PTC Creo Advanced Modeling. My name is Matt Tognerelli, and I will be the moderator. Mansoor Janju will be our presenter for today's webcast. We will begin with a brief BWI intro, who we are, how we help manufacturers with solutions across the product lifecycle for those who are new to the webcast series. Then we go right into the presentation around advanced modeling, along with a live demo, and then wrap up with a Q&A at the end. You're currently in listen-only mode, but you can write in your questions throughout the webinar, and we'll make sure to answer them at the end of the webinar. Barry-Wehmiller International is the global engineering and enterprise consulting division of Barry-Wehmiller, a U.S.-based manufacturing leader with over 10,000 team members and operations worldwide, going on 130 years of business and approaching $2.5 billion in annual revenue. Our division provides total solutions across the product lifecycle, helping manufacturing leaders drive more business and engineering value. Barry-Wehmiller has a rich manufacturing legacy tracing back to 1885, serving all sizes of businesses ranging from small and mid-sized to Fortune 1000 manufacturers. We provide solutions for a diverse group of customers spanning the globe in Europe, Asia, and the U.S., from small companies to large household names and everything in between. Some of our well-known clients include PepsiCo, Polaris, TRW, Anheuser-Busch, and many more. We have a few quick poll questions, and then we will pass it on to Mansoor. First question is, what version of Creo are you currently using? Yeah, thank you. Next question. How often do you attend CAD training during the year? All righty, thank you. And the last question here. What webcast would you like to see in the future? You can actually choose multiple here. So, all right, thank you, everyone. We appreciate your help there. And with that, I'm going to make Mansoor the presenter and have him do his presentation on PTC Creo Advanced Modeling. Switch this over to you, Mansoor. And you should now have control, Mansoor.
All right. Thanks, man. Thank you very much.
Mm-hmm.
Can you see my screen now?
Yes, we sure can. Thank you.
All right. Thanks. All right, good afternoon, everybody. My name is Mansoor Janjua, and I'm the applications engineer with Barry-Wehmiller. And the topics that I'm going to cover today are listed here: curve through points, curve through equation, curve from cross-section, relations, datum graph, wrap feature, flexible components, and then the subblend. The reason I chose the curve, as you will notice in the list, we will be dealing with the curves quite a bit. And curve or datum curve or the sketch is one of the most versatile, feature in the Creo. And you can use it for your sweep, for your blend, for for boundary blend. So you can use this at many different in many different features. So that's the reason I actually chose these topics. So I'm going to start with the first one, which is curve through points. So basically, how do we create that, and so first I'm going to show you the. So you can quickly create a datum curve through a number of points. When those points are created as a point array, you can use a spline that enables you to create the curve through points. So the first thing is you actually need to create the points, and then you will create a spline that will pass through all of those points. So you can select these points in one shot, or you can individually select them and then define radiuses as the curve passes through, or the straight line passes through one point to the next one. So let me demonstrate that idea. So in this case, I don't have points right now. So first, what I need to do is to basically create points. So I'm going to go and select offset coordinate system to create the points. And I now am going to select a coordinate system with respect to which I will be creating points. So in my reference, I select the coordinate system, and then inside, I'm going to start clicking on in this. And these are the coordinates x, y, and z with respect to the coordinate system that we have defined here. So I can give some values like 5, 8, and the z 3, and the x 4, and the 6, and 8. So I can continue adding these points, and then if I want to save this point so that I can use later, so I can save at this point, so I can click on the save, and I can give it a file name, and it will be stored as a .pts file, which you can open up in the notepad. So you can make all these changes to the point, or if you already have this a point file, so let me just quickly open up this file and show you exactly how it's going to look like. Okay. So this is your notepad file. So you have all these points, x, y, and z, and so this is one points file that I have created. So then if you have the points file made, either you can make the points, or in this case, if I already have those, I'm going to delete those points. So we have the coordinate system defined, and I will import the points that have been created or from the notepad file. So I'm going to import it, and then this is the point file. So I will import those points, and as you can see, all the points have their coordinate system defined in x, y, and z. So once I have the points defined, I can now go and select curve through points. So I will go ahead and select this. I can individually select these points, so one at a time, and or I can quickly right-click, and then all these points get selected in one shot. So right-click and then left-click, and you can see that it creates a spline which passes through all of these points. So if I don't do it this way, then I can manually pick one point at a time, and then you can make those either a spline or a straight line, and you can also add radiuses as the curve passes through one point to the next one. So I'm going to delete these ones here, and then simply select So the curve, so this actually, as you can see, is a 3D curve. Okay, so once the curve has been created, you can go and use a sweep feature, and you can just create any sketch, which will just follow the trajectory. Okay, so this is a curve that is created through points. So the next topic in the list is the curve through equation. So you can create 1D, 2D, or 3D curves using a mathematical equation, and you can define either the Cartesian coordinate system, cylindrical coordinate system, or spherical coordinate system. And there are two ways that you can define the curve. One of them is called the parameter t, and the parameter t ranges from 0 to 1. So for example, if I want to create a curve in the Cartesian coordinate, so I will define x is equals to 35t. So t takes in the value from 0 to t, which is, so it starts out 0 and it goes all the way up to 35. So that basically is the straight line here. Then you can also have the parabolic. So x starts out from 0 to 35, and then y basically is 0, and then the z goes into, so starting from 0 all the way to t squared, which is also 1, but so in between it's going to give you the parabolic curve, and you can also get the sine wave, so based on the parameter value from between 0 to 1. So I'm going to create a few curves using the parameter t, and then I will show you the other way of how you can make the curve through equation. All right, so I'm gonna so to create the curve through equation, I'm gonna go to Datum. Under curves, I will select curve from equation, and at this point, I have to define what I mean the system I'm using is a Cartesian coordinate system or cylindrical coordinate system. So I'm picking the Cartesian, and then I also need to pick up a coordinate system. So I will pick the default coordinate system in this case, and then I will define the equation. So equation, I will write it here. So x, I want it to be 6 times t, because the variable t ranges from 0 to 1. And then I also have y is equals to 14 times t to the power cube. And in this case, it's just a 2D curve. So z, I'm keeping it as 0, even though I don't need to put z. So I press OK, and I can look at this. So this is how the curve actually looks like. So this is a two-dimensional curve in x and y. And I can always go back and redefine the curve if need be. Okay, so that's basically the first curve that I just created. So now I'm going to also create the curve in another coordinate system. So this one, I will define the curve in the cylindrical coordinate system. So I will pick the cylindrical. Again, I will pick the same coordinate system, and I will go to the equation. And this time, the equation will be written in terms of the x, I mean r, theta, and z. So r, in this case, is 0.25 plus t times 3. So basically, r starts out from 0.2, but as t is 0, and then as t goes up, so the maximum r would be 3.25, and then the is equals to t times 360 times 10. And it's a good thing to before we actually exit, it's a good thing to always verify that the equation that you have written is it good or not. So you can always go and verify this equation. So relations have been successfully verified, and I can press OK. And if I look at the so this is how the curve actually looks like. So again, you can go and use this curve for your sweep feature or for so the next one in defining the equation through equation, the other one is that you can define this equation explicitly. This is an explicit equation that instead of defining in terms of parameter t, you are defining your y in terms of x, and your z will also be in terms of x. So you will have only one independent variable, and the other two variables will be defined in that. In the parameter t, we can only range from 0 to 1, and of course we multiply with other things to to basically get a bigger range. But when you're using an explicit equation, the independent variable can take any values. Like you can basically go from minus pretty high number to a positive high number. So let me just define one equation or like a couple of equations in the explicit form. So I'm going to delete this one. So I will go back and define the curve from equation, and I will pick the Cartesian. I still have to pick the coordinate system. Once that's established, I will go to the equation, and so equation in this case is y is equals to 100 times sine 2 times x, which in this case is the independent variable, plus 10. Okay, so that's an equation, and I can verify this. So right now the x value, which is, as I said, it can range from anywhere, but it is only from 0 to 1, so I can change it from 0 to maybe 20. Actually, so let me just first exit out of this, and then I will give the limits for okay. So you can define this, or even if you want to go back, you can define it to a bigger limit, because I have a sine wave. So let me at least get it up to this. So you can see that the sine wave is generated for x of 360 degree in this case. So that's the equation using the explicit form, having one independent variable. I will also go and make another one in terms of cylindrical. So curve from equation, you will pick the coordinate system, and I want the cylindrical coordinate system. I'm going to define the equation. R is equals to 1000 and z is equals to 5 times the theta, THE, so I will look at that. So as you can see that it's giving me an error message that I have. So R is equals to 1000, Z is equals to 5 times theta. Okay, check your relations, everything looks okay. And then the limit for this is also from 0 to 360. And this is how the equation, how the curve looks like. So you can see that this is the curve through equation. And the next one in the list is creating a curve from cross-section. So you can use the curve from cross-section option to create a datum curve from a planar cross-section by selecting the cross-section. So basically, we will create the cross-section first, and then using that cross-section, we will generate a curve, and that curve can be used for the feature that I discussed earlier. You can use it in variable section sweep, you can use it in boundary blend or swept blend and other features. Okay, so I'm going to close these. So curve from the cross section. All right, so I'm going to go ahead and create a cross section. Okay, so a cross section has been created, and I just want to make sure that I include the selected quilt. Okay, so a curve has been created here, but the cross section has been created. But what I'm going to do, either I can, no cross section, and then I can simply go and define this curve from cross section, and I simply select this over here. So now this is a curve that I can use. So I can use this curve pretty much for any feature. So you can see that I can use this curve to define okay. All right, so the next topic in the list is defining like relations. So relations are user-defined equations written between dimensions or parameters. Relations let you capture design intent by defining relationship within the sketches, features, parts, or assembly components. So relations they can be simple assignments, equations, or complex conditional statements. So I mean, you can use relations for your design intent, how you want the part to predictably update as you make any changes, and I mean, you can also write comments in exactly how the part will update as you make some changes to any of the dimensions. So I'm going to open up a couple of parts for relations. So in this case, what I want to actually establish a relationship between this hole and this hole, that I want the diameter of this hole to be always 1/4 of this diameter. At the same time, I want this diameter to also depend on the length and the width of the part. So if the length of this part is greater than the width of the part, I want a certain diameter. If the length is less than the width of the part, I want certain other diameter. So, and after that, once the diameter is established, only then this diameter will be 1/4 of that. So that is what I'm trying to create in the relation. So I will go to the relation, and I will pick all the dimensions that that I can see. So I'm going to define in terms of if statement. So if D2, which is this dimension, is greater than D1, and I can give some space in between so that it's easy to follow. So if D2 is greater than D1, then I want this dia, which is this diameter 1, to be equals to 60. And if otherwise, like again, if D2 is less than equal to D1, then I want 1 to be equals to 40. And I also want to establish a relationship between this diameter and this diameter. So I will say this dia 2 will be equals to dia 1 by 4. So as we are basically looking at this diameter, so it no longer is an independent variable because it's dependent on that. At the same time, this is not an independent variable because I cannot change the value. This dimension also is coming from the relation that we are using based on the conditional statement. If D2 is greater than D1, then it will be 60. Otherwise, it will be 40. So I cannot change this. I can only change these dimensions here. So I press OK. So, and I will go and regenerate this. And you can see that because this dimension is greater than this, so this diameter should be 60. And if I try to double click to change it, I cannot. But I can definitely go and change this extrude dimension. So now if I make this smaller, so let's suppose I make it 199. Okay, so now this diameter actually becomes 40 because this dimension is less than the width of the part. So with this, like, you can establish different type of relations so that your part basically update predictably, and you can always go back to relations and you can modify them. You can also write comments in your relation. Okay, so this is a comment, and before you exit out, you can make sure you verify your relations, everything is okay. You can also insert some built-in functions, so sine, cosine, other ln, log, so different functions you can put in. Another relation that I'm going to create is for the pattern members. So I want the pattern to basically update, even though if I make any changes to the pattern members, I want them to be equally spaced on whatever the overall length of the part is. So for this, I'm going to establish a relation. So I will click on the features either from here in the model tree or on the part itself, and then see exactly what dimensions that you can have. You can see them either symbolically by just switching the dimensions, like symbolically, or you can see them numerically. So the relation that I want to establish, that this offset distance, I want it equally spaced on all in between and also in the front at the end. So I will say offset is equals to the length, which is the overall length of the part, divided by the number of pattern members, which is this one, plus one more, because I have extra space here. So I want to divide it plus 1. Okay, and this is the same that I want for the spacing also. The spacing is also equal to the offset because I want equal spacing. So I can verify the relations, everything looks okay. So now when I go and I try to change this direction pattern, so instead of having 5, I can have 4 members. And you can see that they are equally spaced now. So the offset and the spacing between them have been controlled using the relation. All right, so the next topic in the list is about datum graph. And a datum graph can be created as a feature in the model tree. So the datum graph is created more like a sketch, but you don't actually see the sketch. It's kind of an embedded, but you can use this datum graph to modify the geometry, and it's actually drawn only in terms of x and y function, and then there will be something else that I will talk about using the trajectory parameter. And the trajectory parameter is very similar to the parameter t, that can only take the value from 0 to 1. So it can only range between 0 and 1. So let me go and define a graph feature. Okay, so all right, so I'm gonna go ahead and create a graph, actually somewhere over here. Okay, so to create a graph, I will go to the datum group, and in here we have the graph, and this is, I can give it a name. I will just leave the generic name graph_1. And for the graph to work, you definitely need to have a coordinate system. So I will create a coordinate system, I'm going to create the horizontal and vertical line, even though the only thing that you need is only the coordinate system, and after that you need to create a sketch. And I will also use another center line for the overall dimension for the graph. So this is 120. And I can basically create any graph or any shape that I want. Okay, I can dimension it, or I can just leave it like this. So this is my graph, and I can always go back, and if I need to modify, select OK, and you can come back to this graph, and you can make changes if need be. So I have another section, which is the variable section sweep. So I created this as a sweep feature. I will go and so this is the sketch that we had, and then I simply went ahead and just made a sweep. So now I'm going to modify the sweep, and I will just go and pick the section. Okay, so I will. So I'm going to show you like a couple of things. One is how can I use the datum graph, and even without the datum graph, how can I actually modify this shape? Because this one we are using. This is a constant section sweep. So in this, the cross section does not change. But if I need to change the cross section, then I need to use a variable section sweep, and that basically is the sign for the variable section sweep. So now I go to the sketch, and I will now go back to the tools, and under tools I will again go back and use a relationship, and I want this height to change. I want this SD3 to change as it the sweep feature, like the sketch moves along this trajectory. So I want SD3 dimension to vary. So in the first case, I'm going to change it like 20 plus 5 times sine, and as I said, I'm going to use the trajectory parameter, which is pretty much the same as the t variable, which takes the value from 0 to 1. So trajectory parameter also takes in a value from 0 to 1, 360 times 5, or like 4, and I will close this bracket. So basically what this is saying, that at x of 0, when it's at this end, the trajectory parameter value is 0. So all of this will be 0, sine of 0 will be 0, so the overall height will be 20. And as basically we go over this whole range, so the trajectory parameter will start increasing, goes from like at 0.25 times 4 will give you 1, so 360 times 1, again this will be 0, so you again will have a height of 20. So it kind of increases, then it goes down, then you at 0.5 again it goes down, and so on. So if I look at this, I mean it gives you again the sine wave, but the height will not, the minimum height that it will attain will be the 20. So this is like you can define this using, but I mean this is a regular equation that I have used based on the trajectory parameter. We haven't used the graph that we just created. So I'm going to make this as a comment that I mean it will not affect. So so this is just a comment right now. So the second relation that I'm going to establish now, so I will call this SD3, which is this height, equals to, I want to evaluate the graph, and this is some function. This is a built-in function that you can obtain, either type it in or you can obtain it from the function list. So evaluate graph, and then you, in the quotation, you have to give the name of the graph, so which is the graph one that created. And I will also have to say that trajectory parameter, so you start from 0 all the way up to the width of the graph, which in this case is the x. Okay, so okay, yeah, I mean not the x, the overall length, which we made as 120 for the graph. Yeah. So yeah, we are defining in terms of x and y, but the x in this case is 120. So I will make sure that my relations are okay. So now when I go check mark, so if you recall, the starting point of the graph was 33, and then as it went over, so this is kind of the sketch that we made for the graph. And if you go and modify your graph, this will also update. So okay, so this is the overall height. So I can go in and I can change some of this, and so you can stuff like this. So you can see that the so you're controlling the geometry using the graph. So the next topic in the list is that's also a pretty neat topic, because you can, so this is a wrap feature. So the wrap feature, so there are certain things that the curves or the sketches you can make using the curve through points, or you can make them curve through equations, or using the cross section. But then there will be some curves that you cannot make using a regular equation, or like even a curve like this, which you want to go over the surface, which you cannot create based on an equation or any other way. So the wrap feature is very useful for that. So I'm going to show you. So in this case, what I have done, I actually have created an extrude using a surface. So the reason I'm using it a surface is so that you can hide after the curve has been wrapped around. If you make a solid, you cannot hide that. So I will go ahead and use the wrap feature. So under editing, you can select the wrap, and then I will select the quilt. In this case, that's the quilt is automatically selected, but if need be, you can select it, and then you will go and define your sketch. So I'm going to click on define, and I will pick this as my sketching plane. Okay, so I will just draw a line like this. Okay, I will give it, specify a height, or even I can extend it. And I also need to define an origin. So in this case, I'm going to define the origin. This is the point for the origin. And as soon as I go, so you can see that the curve gets wrapped around. You just have to have a more length for this line, and then it will wrap around this feature. Okay, so I can go ahead and I can hide this, and you can also use this for your any sweep feature that you want. You can define it, go and create a sketch. So you can see that so for regular, so this type of curve you cannot get it from regular datum curves. You have to use a wrap feature to obtain this. Another part that I want to show you is this wrap over here. So in this case, I have this, and I also have curve made. So this is the surface, and I want this curve to wrap around this extrude feature. So when I go to editing, I go to wrap. So I select this quilt, and then I can either define this sketch, or I can actually select this sketch. So I'm picking this sketch. In the previous case, I did actually mention that you have to create the origin about which the curve will wrap. But there are two ways to actually do that. One is that you either have to create the sketcher coordinate system or creating the center. So the difference, so the reason you have to create the coordinate system, because it will automatically, if you use the center, whatever the curve will be, it will just pick the center point of the curve, and you want the projection of that line, at least the half point, has to be on the surface itself. If you make a long enough curve that this center is above it, it will not wrap around. So that's why you kind of make the coordinate system so that you know that it always will be wrapping around, because if I make the coordinate system over here, then the curve will be, we know that it will start to wrap around from here, so it will be projected onto the surface. So if I make this curve any longer, because we are using the center of the sketch and not the coordinate system, so the feature will fail. But in this case, it should be okay because it is still projected on this. So I will just hide that extrude, and you can see that it was a straight, it was at an angle, so then you have this feature which you can, again, you can go back and you can use a sweep to make it. But going back to my previous point, if I have this curve and I make it any longer, the center point will change and the center point will no longer be projected on the curve. So if I do that, the feature will fail. So to avoid this, whenever you are making, so in the previous case, that's one of the reasons I actually went and I created this wrap feature. I mean, not here. So I'm going to unhide this. So I'm going to make another wrap feature here. So in this case also, if I pick this and I make a line which is like, something like this, because the center of this will be somewhere over here. So if I try to wrap it, the feature will fail. I mean, it will not work. So for this reason, I actually had to create the coordinate system. So I will have to go and define the coordinate system, so that once you have the coordinate system defined, then the projected, so now it's starting to project it from here, which is still on the surface itself. Even if I try to make the coordinate system here and then the curve, because there is no surface, so the feature will also fail in that case too. All right, so that's the wrap feature. So let's just go to the next topic in the list. The next is the flexible components. So components such as springs, clips, brackets, hoses, wires, cables, rubber, washers, all typically vary geometrically in their assembled condition. So if you design a spring and you give it a certain length, and you are using the same spring in different places of the assembly, and the distances can vary as you place that spring, so you can make certain dimensions to be flexible in terms of whenever it goes to the assembly, it will ask you to vary only, or you can keep the same dimensions, or it will ask you to vary only certain dimensions. You don't actually are creating the new parts. If you have a bill of material, in the bill of material in your drawing, it will still be showing this single component, but you can have different lengths as you are assembling it. So Creo Parametric enables you to add flexibility to a component by changing the value of a selected component items. Note that this change is only within the assembly. So you can actually, and the part remains unaltered, like this is the part, so whatever the length of the part is, it will stay the same, but when you are putting it into the assembly, that's when it's going to change. You can make dimensions flexible, you can make features flexible. What I mean by features, I mean dimension, of course you can change the length, but what I mean by feature, I can suppress, if I pick those holes as the features, I can let them resume, or I can suppress them when we are assembling it. I can also pick other geometric tolerances, surface finishes. I can also make those features as flexible as we put them in the assembly. So that's the idea behind it, and let me now show you how we can actually so to get to that, so there are a couple of ways. One of them is if a component is already placed in the assembly, I can make the component also flexible over there. I mean, if I'm making any changes to the assembly, I can make only that component flexible. Or otherwise, what I can do, I can make this spring flexible, and anytime then you bring into the assembly, because if I just do it over here, the next component, the next spring I will bring, that will not be a flexible. It will only be making the flexibility, or like making this component is flexible. So if I select this, okay, so I'm going to change this, and I'm going to make this flexible. And I will pick this again, this all. So I have this dimension. So I'm going to change one of this dimension. Okay. Okay. So this dimension, which was the. So how do I want to change it? I can actually change this by value, or I can change it by distance. So I'm going to pick this surface, hold the control key, and pick this surface, because these are the surfaces that were used to place this component. So now, as you can notice, initially when the spring was installed, it had the dimension of this, but we are trying to control it from this side to this side between this this distance. I press OK. So now when I go and I mean, this is an assembly, so let me just go back and modify this. So I go to edit. So instead of 4.5, I make it to 3, and I regenerate, and you can see that the because of the flexibility in the component, but if I open up this back in the, so it still has the same length what we started out with. So I can always go back and look at this overall length. Yeah, this is so you have the 4.392, which is the length of that feature, but because it's now made flexible, so it can be varied. So the same thing, and I can, if I need to, like for example, if I bring another spring, which is the spring rod here, I mean, this component itself is not flexible, because as you can see, it did not ask me for anything or any dimensions to vary. So this is kind of whatever the dimension that we had, it's just coming for that dimension. But what I can do, I can make certain components flexible. So the feature that I want to, okay, so this is the component that I want to make flexible, so that when we go into an assembly, every time it asks me what features do I want to change and so on. Okay. I think probably this this feature, I was working on it, and it's okay. So I'm going to just delete that feature. Okay. All right. So what I'm going to do, I will go ahead and add flexibility to this bracket. So I will go to File, Prepare, under Prepare Model Properties, and in this I will make it flexible. So I will go and change. So do I want to change the dimensions? I can also add features. So I will basically first pick this, and then I want to change this angle dimension. So the part is designed at 102 degrees, but when you are assembling it, more likely, I mean, it will be 90 or some other angle. So I will pick this dimension. So this will be the dimension that I can vary. At the same time, I can add some features. So I can pick this hole here. I can hold the control key, pick this hole. So those are the features. Those are resumed, but I can also make them, change when we put them into an assembly. All right, so I'm going to save this. So now I go and open up an assembly where I want to place this component. So I will go back and I will bring in this metal bracket. If I want to place the metal bracket in its default dimensions and the features, I will press no. But if I want to have the flexibility brought in from the part, I will press yes. So now you have the dimension that you can change. This is the original value. I will make the new value as 90. And even for the features, if I don't, the new features, I can suppress those. Okay. So after this, I can simply go ahead and do the, select this, select this. I can also place it make it coincident, and then I will also pick this surface here, and I will align, so somewhere over here. So you can see that the component has been placed, and if I need to, I can always go back and modify a few things, So if a component has been placed or you change their flexibility, you can always go to Edit Definition, and there is a tab for the flexibility. You can look at the varied items, and if I need to make any changes to the dimensions or to features, I can go back and resume this one. So now you can see that there is an additional hole there, so that feature is resumed. So under Flexibility tab, you can go back and you can make those changes. All right, so the last topic that I want to cover is the swept blend. And the swept blend enables you to simultaneously and blend multiple sections along the main trajectory. So swept blend is a pretty powerful tool in terms of it's a combination of a sweep feature, and it also takes in pretty much everything from the blend. So the blend, so what the blend is, like you have multiple sections as long as they have the same number of vertices. So the start point of this blends with the start point of this, and then the start point of this section, and then number of vertices have to be the same, and then this is the trajectory on which you can make those sections. So you have the sweep feature, which is coming from the trajectory, and the blend where you have multiple sections that can be created. So let me just show you this one. Okay, so in this case, so this is the trajectory for the sweep, and these are the sections that have already been made. So I will also, so first I will select those sections to show you, and then I will make a quick swept blend feature, how you actually will make it yourself. So I will pick the swept icon, then under references, I will select the trajectory, and then under sections, I will select the sections. So this will be my first section. This is the start point. I can change the location of the start point if need be. The number of vertices are the same, and in this case it's 4. I will go and insert. I will pick this. So this is the start point. I can change the start point to this location, and the number of vertices in this is also the same. And I will pick this. The number of vertices also need to be the same. And the way the way this works, so if I go to this sketch or this sketch over here, actually, this one or the last one, so I go to this sketch. So the divide tool, I mean, when you draw the circle only, I mean, doesn't have any blend point, but you can use the divide tool to basically break a segment into. And so right now, if I select the line, I can select the whole line, but I can use the divide tool to break it into multiple segments. So now these are independent segments, so I can, if I need to, I can delete it. The same way how it's been done here, that the circle has been broken into multiple segments so that the number of blend points, the number of vertices in this have to be the same as the number of vertices in this section. So let me also make a quick swept blend based on that. So if I start out with a sketch, you know, so I just go with a spline. So now when I exit out of this feature and I basically go to the swept blend, I don't really have any sketches, but if I go to the swept blend, I pick this trajectory, I go to the sections, either I can select or I can sketch. I will go to the sketch. So this is the sketch location. I pick the circle here. Let me just change the, okay. And so one thing that I want to do, I mean, this is giving me the end because you need minimum of 2 sections, but I don't want at the end, I want to create the section somewhere in the middle. But really, I mean, I can't pick any of this right now. So I need to do something to this trajectory so that I can actually select intermediate points where I can draw these sketches. So one thing that I can do, I can go back to the trajectory. And as you notice, I mean, I can either use the divide tool to break this, or what I can do, I can simply go to the point and I will create these points here. And I will use the coincident constraint to just simply connect those points because I can control the dimensions of these. So now when I go and I use this swept blend, I can go ahead and sketch section. So the second one that I want to do, I want to pick this, sketch. Okay, and the third one I want to select is this point here, sketch. I will use an ellipse. Okay, and the last one, I want to pick the last one, and I go to sketch. And you can see that it kind of, I mean, depending on what you want to create, you can do that. So yeah, that's pretty much what I wanted to cover in this, and I will give the. So Matt, I'll leave it up to you to finish this, and if anybody has any questions.
All right, Mansoor, thank you. Yeah, I'll take it over from here. If you have any questions out there, please submit the questions right now, and we'll start answering them as we go along here. Alrighty. Again, if you're looking to take any other PTC classes or just kind of take your skills to the next level, we do provide PTC certified training in 8 training facilities. We can also do on-site training or virtual training as well. Feel free to browse our training schedule by visiting the events tab on our website at b-wi.com/training. You can also reach out to our National Training Manager, Joe Ferret, directly if you have any training questions. He'll be able to take care of you as well. I'll leave this screen up for you, so that if you have any questions or would like to look into those while we answer the questions, you can take note of those. All right, got lots of questions. here, Mansoor. I'm going to keep you busy for a little bit.
All right.
All right. The first one says, if you don't use t, does it just create an offset? For example, if you use a set y equals 2, would it just offset the curve in the y-axis by 2 units?
Yes, if you don't use the t, and if you just use the number, it will only offset in that particular, in particular axis. So yeah, that's what it is.
Okay. All right. The next one is, where can I find a list of all available parameters to use in equations for modeling, like in sweep, blend, etc.?
Actually, the functions are in the relations. You have all the functions that are available for the. And you can use them in any of the features. It doesn't really matter. Like, yeah, you can use relations and those functions in any feature.
Okay. That question's for me. The webinar will be sent out to everybody afterwards as well, the copy of it, and we'll also post it to our YouTube page. Let's see. Did you already make a relation for the spring to change it as it's pitched based on the length?
No. It's just a regular spring. You can make it, but it's just a regular spring. So when you make a flexible, there's no. You can make a regular spring without having any relation, and it will still update. So if you want, more advanced way of making springs, there are ways you can use the material properties and everything, and you can get the diameter based on the strength and everything. But yeah, the spring that I was using, there was no relation that was used in it.
Okay. In a dynamic analysis, can I assign specific characteristics to the spring, like ramping or stiffness?
Actually, that's the dynamic analysis that you. That's completely separate thing. Like, this is only for the visual purposes, and the dynamic analysis, like, you have to be in the mechanism, and over there you are, changing the properties of the spring. Right now, it's just for the visual purposes.
Okay. Can you show blend point on the variable section sweep?
Can you show a blend point on a variable section sweep?
Yes.
I don't understand the question, actually.
Okay. Dave Fisher, if you're out there, if you could give us a little clarification, we'll work on that. If not, we'll try and get back to you later on this afternoon or this week and see if we can help you with that. It says, okay, he said, it looks like one of the follow-up questions would be, all right, so in relation to the, can you show a blend point on the variable section sweep? He came back, Mansoor, and said, he said it lets you use less sections on the concurrent section.
Yeah. I don't know. Yeah, so probably, like, so you can reach out to me. I should have listed my email address or like my phone number so that you can reach out to me directly. But you can contact Matt, and then you can get hold of me. I'm in St. Louis, so feel free to reach out to me if you have any specific question.
Okay.
And I can always use a GoToMeeting to see exactly what question you have, and I can go over a few things with you. So
yeah, we can get back to them. Let's see Let's see. It says, one says, by parameters, I meant something like a traj part and sweep. The question was, what other parameters are there that I can use with functions in the relations?
the parameters. Yeah. So also I would like you to contact me, and then we can go over exactly what you are trying to do. There are a lot of stuff that you can do. Especially, there is a lot of functions available in the in this. But what PTC did actually with the Creo 3, they also linked the MathCAD portion. So you can actually send out a lot of information, MathCAD, and you can control your geometries using this. So there is a limited functionality that was there in the relation, which is still very useful, but now there's a whole lot of different things that you can do, because you can have an embedded MathCAD sheet, which you can pretty much control your complete models. This is a loaded question. You can do a lot of different things. You can, based on the material, based on the strength, the loading conditions, everything can be changed now as you use equations and everything. So
we can maybe do a one-on-one.
Yeah, reach out to me, and so we can definitely figure out what you exactly want to do, and we can go from there.
Okay. That's all the questions. Let me, we'll wrap up the rest of this here. The PTC has a Get Active promotion going on right now. When you trade in your old licenses, you can get a new subscription license and save up to 80% on it. With a multi-year agreement, you can lock in the low price. Your annual subscription covers software support and training. And that's just one payment and no surprises. Also, up until June 24th, you can also save 35% on PTC Creo simulation. And as a reminder, all of our webcasts are on our website, b-wi.com, Webcast. You can view at a later date or at your convenience. And with that, if you have any questions about the webcast today, technical questions or requests, send them to myself, Matt Tognerelli, at b-wi.com. My information is listed here. I'll take care of you and get your requests taken care of, either with the main store or one of our BDMs, and do the best to get all the answers that you need. Everyone, thank you for attending. Have a great day, and we look forward to seeing you at our next webcast. Mansoor, thank you very much. Great job today.
All right, thanks, man. Thank you.
Mm-hmm.